In our previous tutorials, we've looked at a few different ways to make targets. This tutorial will focus on the other input of the Move component, the motion settings. We find motion settings in the Motion tab, Motion Settings. I can connect that component straight to the motion settings input of Move. There are 4 main settings that we give you. The first is space. If I right click on space, you can see I have the options of Cartesian or joint. Cartesian moves will be straight lines or arcs. Joint motion means that each of the joints will move in a linear fashion directly to its next target. That can create slightly unpredictable movements, but we visualize them for you to help you see what's going to happen. If I select joint mode, we can see that all of our lines have suddenly become dashed. That's because at this particular moment, we're not exactly sure how the robot's going to move between those points. If, however, I solve the procedure, we can see that these curves suddenly appear, and those are the movement that the actual TCP is going to do whilst we're executing that motion. I'm going to switch back to Cartesian to demonstrate some of the other parameters. The speed settings can also be found in the Motion tab under Speed Settings. The basic form of this component allows you to change the TCP position speed and orientation speed, as well as choosing the units in which you want to work. The acceleration settings are extremely similar, and both of these will show up when you simulate. If you increase the speed, the simulation will go faster, decrease it, and it will go more slowly. The blend settings change the approximation of each target. That is to say, how close the robot can get to a target before it decides it's actually hit it. To demonstrate this, if I plug in a 100mm blend radius, we can see these rings appear. That means that the robot is going to hit somewhere within that ring and consider that it's reached this target. It will then start its motion over to the next target. I can change the size of this blend radius to my heart's content. But if I want to see what the robot's actually going to do, once again, I need to solve. When I solve, you can see that these blends are actually represented. That is to say, we don't have the circles anymore, and we now have a smooth arc between each of the targets. This will continue to update as I change the blend radius.